Alright, so this is part 2 of Freefall, and basically starts off with one slide, and this slide is the only slide in part 2, and it has to do with the equations for solving all of the free fall problems, the acceleration problems, and pretty much anything that has to do with acceleration and velocity and displacement. So if you look at the equations list, there are a total of 4. V is equal to V naught plus AT. D is equal to D naught plus 1/2, open parentheses, V naught plus V, close parentheses, T. D is equal to D naught plus V naught T plus 1/2 AT squared. And finally, V squared is equal to V naught squared plus 2A, open parentheses, D minus D naught, close parentheses. Now, looking at these 4 equations, okay, you should write them down in your notes. But at the same time, what I'd like you to do is pull out your blue equation sheet and find these 4 equations on the blue equation sheet and just put a box around it or put brackets around it. Do something so you take notice of it, because these 4 equations will be using quite a bit for chapters 2 and chapters 3. So go ahead and hit pause and go ahead and do that. Alright, so then now since you have done that, now let's talk about what each of these variables mean. This is just like any equations, okay? Any equation that you have ever done in math and algebra. Basically, any of these variables is essentially a number. And the one variable that you don't know is your quote-unquote your x or your n. You gotta solve for the x or solve for the n. So that's what you have to do. You have to look through the problem and be able to identify which variables represents that number. So v with no subscript is the final velocity. V with a little 0 is v naught, and that's the initial velocity. A is acceleration, and this a could be a lowercase g. As remember from part 1, lowercase g is basically the acceleration due to gravity, and that is always a number. The acceleration due to gravity will always be negative 9.80 meters per second squared, always. And then t will be a number that you read either from the problem or something that you're going to be solving for. Okay, so you got final velocity, initial velocity, acceleration, it could be acceleration due to gravity, and also time. D without the subscript is the final distance or the final displacement. Initial distance, 1/2 is a number, of course. Initial velocity, final velocity, time. Again, final distance, initial velocity, time, acceleration, and time again. And remember, this acceleration could be acceleration due to gravity simply because you just kind of, let gravity do its thing. Final velocity, initial velocity, acceleration, again, could be acceleration due to gravity. The final distance, initial distance. Generally speaking, we would always have an initial position. We usually start at 0. So if you're saying, oh, the car went 250 meters, where did I start from? Well, from 0. So that would be our initial distance typically. But of course, you can do it case by case and kind of see what's going on according to what you're doing. And in that case, you will be able to determine what the initial distance would be. We'll be working on some problems in class on Wednesday and on Thursday, and hopefully that will give you a kind of a cue as to how to utilize these equations. But the biggest challenge to this whole thing, it's not the math. It shouldn't be the math. In fact, the biggest challenge is reading the problem and pulling out the variables. Well, that bell signifies the end of this last slide, coincidentally. So at any rate, we will be working on this in class. So see you then.